Hi everyone, I'm Pengyu. I will introduce a joint work with Marinella, Zhiqiang, Sarfraz, Alex, and Milos, unifying execution of imperative generators and declarative specifications. Our work is motivated by the recent research on executing declarative contracts using a set solver without imperative implementations. There are several limitations though. Contracts are traditionally written in a declarative specification language, which can be quite different from general-purpose languages. Also, they cannot benefit from partial imperative implementation. Users need to choose all or nothing. The entire method is either executed declaratively or as a regular imperative method. In addition, executing contracts by translating to set formulas can be time-consuming and not scalable. We present a framework called Deuterium to address these limitations by fusing imperative and declarative styles for writing and executing contracts. We enable writing contracts using general-purpose languages, specifically using Java and a domain-specific language, 2H, embedded in Java. Users can write a part of the contracts as imperative generators, and Deuterium enables the fused execution of generators and declarative specifications to reduce search space and speed up the execution. We also enable executing contracts using in-memory state exploration. I will use a binary search tree example to illustrate how Deuterium works. Suppose we are executing the contract of the add method, which adds value 2 to this tree with 5 nodes already. The first step is to check preconditions, such as whether the value is already in the tree. Then, Deuterium invokes the generator, which should generate a backbone structure of the solution, for example, the shape of the binary tree with 6 nodes. Finally, Deuterium invokes the solver to complete the execution by filling the missing values. Deuterium supports two solvers. The set-based solver translates heap and specifications to relational formulas, uses a relational logic solver based on a set solver, and then translates back the solution to the heap. The in-memory search-based solver performs in-memory state exploration to find a heap state that satisfies the post conditions and invariants and avoids the back and forth translation from and to a set solver. This slide illustrates the contract code we write for that add method as a combination of an imperative generator in Java and declarative specifications in 2H. A large portion of this contract, including the invariants, specification fields, and generators, can be reused for contracts of other methods in this class. This slide summarizes all our contributions. More information can be found in our paper, the full talk at Uppsala, and the GitHub repository. Thank you.